Then, hi and welcome. My name is Manuel. I'm with Vector and I'm here the second time. I already pitched this project in our last community days event very briefly in the evening. So this time I have just a short recap. I have some update for you and I would like to show a live demonstration to share the details. So in the meanwhile, as promised last time, the first upload is done. We have content in our project repository with some documentation demos included. Getting started. So if you want to get hands-on, you can do now. And before we start with the demo, let me shortly wrap up what it's all about. So the application framework idea, it's a new project below the Eclipse Automotive API framework. That's the title of our Eclipse project. And the idea here is to make application development for HPC ECUs more easy in the sense of to decouple the application layer from the lower layer middleware. So as written here, to make design, implementation, and test of distributed automotive applications more easy. And the idea of the application framework is to introduce a thin abstraction layer to the microprocessor stack, as illustrated on the right-hand side. And it's not only the stack, but it's a complete workflow and a tool that comes along with it to work with this layer, to configure and to deal with it. This workflow covers everything from project initialization to building and testing the binary executables in the end. The whole solution lies at compile time and it puts the focus on executables. What does that mean? So let me shortly stack up the whole framework. On the bottom, we have a data model. It only covers the relevant aspects. We have model packages for middleware agnostic parts, but also for middleware related aspects. On top, we have modern approach, configuration as code, so no tools, nothing, no separate tools needed to work with it. Everything is text-based in Python, so configuration of this layer works just as programming. You don't even have to switch the environment. Then it's clear that there are already a lot of solutions out there. And that's why we see import from different existing formats, IDLs, description formats, kind of as crucial in order to be relevant. So one possibility named here is the Covisa VSS format, the catalog we have already heard about today. But that's not limited to it. It's open to others. So we could also think of import from Branca, from AutoSAR, from you name it. Yeah. From this configuration layer, we export into a database model exchange format, which serves as only touching point with a layer for generation. So in the development projects I have seen, there's a lot of boilerplate, a lot of stuff on the executable level that needs to be written, that needs to be maintained. And that's why generators can help to relieve you from everything that's repetitive or that can be automated. This is APIs, for example, for communication or persistency, but also all the build environment testing stuff that is involved. Either side, an application also needs other more static aspects like logging, error handling, state management, or runtime aspects that are relevant to make a binary executable functioning. Now, if we map this to an executable, we see state-of-the-art today is you have the middleware interfaces. This could be, for example, AutoSAR adaptive, but this could also be the S-core interfaces we have learned about earlier. But you see, intentionally, I left a lot of white space here. So this is about to be filled by the application framework. And here, those generated and static aspects come in and fill that. To decouple from the lower layer, we have middleware abstraction And for the runtime and other stuff, we have the control module. So from the terms you see, it's a modular concept. And on top of that, the framework supports with development. It creates implementation stubs, it creates test stubs, and also the application level itself is modularized. So those application modules, this is the domain of the developer. Here can existing source code be developed or integrated. And with that said, I can also give a clear definition of what an application actually means in terms of this project. So application for us in this open source project also is a thematic bracket. It groups stuff that belongs together. Could be, for example, a lane keeping application or something else. But on technical level, it's clear. It's something that can consist of 1 to n executables. So it's not only an app equal to 1 executable, but it can be multiple of them. And each executable, again, can consist of multiple application modules. Now, that's the recap. This is something I presented last time already. Now let's dive into the technical details. So I've prepared a demo, a communication use case, and I want to show you the 3 aspects here. Design of data types, interfaces, and executables, implementation of those app modules, the business logic, and how testing can work. And the last step, how can integration work? That means instantiation of modules, wire them among each other, and then finally build them, deployable units, which allow then system level testing. In the demo, for sure, this will be just straightforward, but in reality, it's quite clear. We have seen the B model. There is always back and forth. You have feedback loops and iterations. Now, let me introduce you to the demo. So we will start with the Covisa VSS catalog. So this tree structure kind of represents signals and information you will find in a vehicle. And from that, we will start and then see how the different roles we have in a development project, architects or open source community. For example, the VSS catalog is maintained and developed there. We have developers and integrators. Those 3 aspects are present in the application framework. So we have 3 types of sub-projects. The first one is the interface project, and this one allows to consolidate input formats, for example, VSS, others more, and extend it with own definitions, for example, of data types or interfaces, kind of consolidating multiple sources. You see it on the right-hand side. With that said, let me switch to my VS Code. So I have just downloaded the repository, latest version of it, and built the development container with the included build script. And we see here the whole application framework tool is command line based, short VAS, Vehicle Application Framework, and that makes it ready for use in CI. But we also have here integration into VS Code with the Task Runner plugin if you're more on this, if you prefer to click the individual steps. So in the first step, let me create an interface project. For example, choose some name. And now we see here in my workspace, I have a new project in place, and I get a Python file with the name of my project title. And here, some sample configuration as code snippets are already there. Now let's, in the first place, import the VSS catalog. I have mounted this to my VM, to this folder. This is just a VSS JSON export as you find it on the web. This gets imported to my project, and we see here a pair of files. We have a JSON file. This is the model database. This now includes the VSS structure in our application framework format, and we have this Python file, which is used as an importer, if you want so, and it gives a tree structure, which makes easy access in Python with a sub-element. So you see here the tree structure from VSS starting from the root node. And with that, I can now either selectively or globally just import this complete catalog. And I would also like to show you how an own interface definition can look. So we have this abstraction, module interface, and let's turn this on data exchange interface and give it a namespace. And now, guided by my IDE, I can do extend my interface. And we have decided that in a distributed application, even though there are a lot of terms for the communication principles out there, there are basically two basic principles everyone will need, and that's pub/sub messaging and remote procedure calls. Our term for the pub/sub messaging is data element, and I can easily extend my interface with one data element simply by giving it a name. And and I can also extend it with a operation. Same style. So you see, you get guided by the IDE. Really easy to start. And here, for example, let's specify an in parameter. Great. Easy here. Kids. And let's also do an out parameter. Just giving that as a dictionary. Okay. And with that done, I can kind of combine my input from VSS and extend it with my own interface definitions here, and then generate that into the same structure again. I have my database in JSON format and a Python file along with it to kind of import it from later projects. With that, let me switch shortly back to the next slide. Now I would like to show you how I can use these interfaces in different app modules. So for that, again, I can use the application framework. Create a new type of project, app module. App module 1. And again, we get from a template, which is also modifiable, a new project structure, and it's ready to be used. So it contains some dependency management based on Conant, the build environment based on CMake, and the same structure for configuration in config as code. And the first step now here is to import the interfaces from the previously completed project. So I import the stuff to my project. Now I can import it here. You see here, an app module with the name given in the project setup is already available. And now I can start to configure my app module. I can assign consumed and provided interfaces to my app module. For example, I don't know, parking brake consumer. And now I can iterate, guided by the IDE, I can iterate the VSS catalog. So VSS, vehicle, chassis. We see here there's the parking brake interface. What I also can do is now I want my app module 1 to be a provider of this interface I created by myself, the data exchange provider interface. So it's all sorted by namespaces. like that. And that's basically all you have to do on the app module level. You generate the project and what what you get here is a generated implementation folder, and it includes different aspects. So we have here a source folder with an implementation stub. Here you see the generated interfaces for you. So the whole framework is built around an API for data elements you can use for pub/sub messaging and for remote procedure calls, termed operations. Those interfaces are also generated into the source gen folder, and you see they are here sorted into this folder structure, provided as virtual classes, and the app modules, they implement this stuff. So here I'm equipped with a app module stub, implementation stub, and I can, guided by my IDE, directly start to do the implementation. That means, so I have configured the parking brake, so I can do the parking brake consumer to check, for example, the state of the parking brake. Let's add some sample code here. If the parking brake is engaged, let's print some message. Car is parking. Otherwise, car is driving. And with that done, I can build my project. Everything is ready. And I can build it as standalone library to check if the compiler is fine, if everything satisfied here. What I also do have, we don't have the time to look into that, but we prepared for you is also test stubs based on Google Test. And here in my app module 1, you see this unit test is already prepared, so you can directly start implementing your tests with Google Test, as you might know from other projects as well. And with that done, so I will skip app module 2 for now. We can now continue with the last stage, the integration project. And here, the whole thing is instantiated. The app modules get instantiated and wired among each other. And then you can easily connect to different lower layers. So here in this example, in the open source project, we have started with Silkit, just another open source project, but you can think of this lower layer module to be replaceable. I will show you in a second. And to do so, we use the last project type, the integration project. Demo executable. And again, we get a folder as the previous one ready to start, same structure. Again, configuration as code in Python is used to do all the work to do the configuration. And here I want to import app modules. In this example, I have only one. And now I can start to create the executables. So demo executable, I give it a period for the executor. This is for the runtime aspect. Now I can start to map my app module to the executables. So I can also have multiple of them. And we also see here, it was mentioned in the ESCO project, we also do have this one layer above, some possibility to do ordered execution. So we have this executor in place with time slots, and you can specify this here in a simple way. Then wiring is done as follows. You take the executable, Then you use here the API connect to circuit. You specify the app module and from a list. So again, guided by IDE. Select here from this list. Okay. That done, I can also generate the integration project. Time reasons. Okay. So what happens here, I imported the app module project to my integration project, and we see here in the source folder, it's just linked to my project structure. That means the app module created once can be reused in multiple integration projects. And with this wiring done, I can now also build project. I'll show you then the finally running binary executable. Let's come to the summary. So we have now created within minutes from scratch with the framework a demo executable with one app module. We connected it to the circuit platform, and we see here those red boxes are generated abstraction modules. That means from the app module perspective, you can use the same API. You can use data elements and operations, and no matter if you communicate with an app module close by in the same executable, or if some app module in another executable, doesn't matter. The API itself is still the same. And that's the benefit. And with solutions like Circuit in place, you can start prototyping. And later, when it comes to production and Circuit is, for example, then replaced by an S-core stack or by an AutoSAR adaptive stack, you just exchange the middleware abstraction module and you're good to go. So, before I close my presentation, wanted to show you the running example. So I have now in my demo workspace, I have a demo executable, build, release, install. So we see here, everything got deployed to an install folder. Then I will have to run the circuit registry. This is like a daemon or a message broker, take whatever term you prefer. I will just start this to the background. And then I prepared the tester. It will just imitate the parking brake. And now I can start the demo executable. And we see here, car is driving. After a while, the tester will change the signal, the car is parking, etc. pp. And we see with that, as I mentioned earlier, from scratch within minutes, you can start a prototype, set up everything with the app framework. And I hope this was of interest for you. I would look forward to your questions, and maybe we see each other in one of the project meetings. Thanks.
Manuel. So, any questions from the audience?
To share again.
So we have something from the chat.
Now let's see.
So that was definitely.
I hope it's recorded, yes.
Yes.
I joined too late, maybe. That's why I have only the
Okay. So that has a form.
now let
So it's obvious that nobody has changed. Thanks for the talk. If you can reach for your number one contribution from whoever, what would it be?
now that all kind of contribution is welcome, but it would be really interesting to learn from OEM or supplier side what they think about the API we have here for communication. So we have, I've said, data elements, operations. Those are the basic communication principles we think are relevant when it comes to communication. We also extended to for persistency, other stuff more to come. And in the end, this should match with the lower layers out there. So we have learned about S-Core in Eclipse, but we also have DDS-based stacks. We have AUTOSAR adaptive-based stacks, and that would be of interest to see if existing applications out there match with what we have in our API provided.
Yeah,
Now
Mr. Manuel, what is the difference to U protocol then?
Oh, yeah, interesting question. So I think U protocol has a little bit of different focus, at least as far as I understood. U protocol covers more also connection to the cloud, has maybe a different understanding of what an application is. So that's why I brought this definition. Here it's a multi-executable application. In-vehicle communication is the focus here. So we have definitely not thought about connecting anything to the cloud. And U protocol, as far as I understood, is trying to unify different protocols. But I don't see a conflict here. We could also have a abstraction module for U protocol in place here. So that would be for sure an interesting question to discuss how U protocol and app framework could come together, because you have seen it here. We also thought a lot about workflow and tool and how you would like to work. And maybe that's a good combination in the end.
It would be a good thing maybe to get together with each protocol and see if this API can be reused. If you protocol has, for example, an API agent for umpires, for example, to have the workload managed and have an agent here in an app module, what is doing that mode
Can be inside, yes. Yeah, so actually we talked already to the people from U protocol. So yeah, let's see where this goes.
Well, as I know, U protocol doesn't really distinguish between in-vehicle and in-cloud. I mean, Kai can correct me, but basically this is a unified protocol. No matter where in the in-vehicle stack the communication takes place or off it.
Yeah, exactly. So the app framework is supposed to sit on layer above.
Okay, so thanks a lot, Manuel.